Hello everyone. Today our topic is how to return a list of tuples. The tuples contains column names and data type of a data frame using df.dtypes. So this we'll see in PySpark. So how to get the combination of list of tuples as column name and data types. The syntax is like df.dtypes. So here df is our sample data frame and dtypes is the function. So if you write this syntax, what we'll get is it returns a list of tuples where each tuple contains the column name and its corresponding data type. So tuple is like So here starting and ending with parenthesis, and inside that we'll get column name and that relevant data type. So if you see sample output, so if we pass like this df.dtypes, we'll get output as like this. If you observe starting and ending is square bracket, so that means list. So that is this one, list and list of tuples. That means inside list, we have multiple tuples. So this is one tuple and this is one tuple and this is one tuple and this is one tuple. So each tuple will have the first value is belongs to column name and second value is belongs to data type of corresponding column. And similar way, this is second column name and relevant data type. So this is third column name of data frame and its relevant data type. And this is fourth column of data frame and its relevant data type. So if you pass this function, so this particular data frame will get output like this as a list of tuples, and each tuple will have information of column name and its relevant data type. So for getting the column name and the data types in PySpark, we have multiple functions. So in that first method is df.printSchema. So this is the one we frequently use in PySpark. So df.printSchema. So what it does is, if you see the output type, so output type will be none. So it prints to console. So it prints to console means, so if you pass df.print schema, so we'll get output like this. So this is a root. And so here we'll be having information of each column. So that is first one is the column name and that relevant data type and that relevant nullable. So whether nullable value is true or false. So here true is there. Suppose if you see this particular column load underscore date. So data type is date and nullable is false. And these columns also like load underscore time, current underscore user and range. So this is about df.print schema. So this is one of the method to get the output of data types. So this is a quick visual inspection of tree structure. So output will be like tree structure. And second method is df.schema. So what we'll get is struct type. So output will be like struct type. And this is programmatic schema manipulation and validation. Suppose if you see here df.schema, so this is my data frame. Suppose if I print df.schema, so we'll see what it means. See, the we are getting output as struct type. So that is, it is mentioned here. So df.schema output is struct type and it is programmatic schema manipulation and validation. So that means for each and every column, it represents in the form of fields. So output will be as struct type. And if you see inside, the number of fields will be there, like struct field. So this is one first field that is represented with struct field. So that means this is related to first column. So here inside struct field, we have start underscore date, that is the first column name, and that relevant data type, and that relevant nullable value. And this is second column. So second column is product underscore URL, that relevant data type, and whether it is nullable, true or false, and so on. So how many columns are there? So that many struct fields will be there. So this is about df.schema. So next, what we have is df.columns. So df.columns, what we'll get is, we'll get a list of column names. So, but here we don't get data types. So here we'll get only column names. So, df.columns, we'll get a list of columns. So all columns will be string type. So here what we are getting just the names of the column names. But here we are not getting the data types, relevant column data types, we are not getting here. And final option is today's our topic is df.dtypes. So here what we'll get is a list of tuple, and inside the tuple, so both will be string. So as I told mentioned, so first one is list. So list means this one, starting and ending value as square bracket, and tuple. So tuple means this one, this whole thing. So like square bracket, so parenthesis from here to here, this is one tuple. And inside tuple, we have string. So string and string. So this is one string, that is column name, and this is one string, that is data type. So this is a quick mapping of names to simple type strings. Okay, so we saw how output comes based on different methods. So here I will try to print df.print schema also, so that we'll get idea if each function how output it displays. Okay, so first one is df print schema, second one is schema, third one is df.columns, and fourth one we are going to discuss about df.dtypes. So now this we covered. So next one is, in this our main topic is this one, df.dtypes. So first we'll see what is the key features of df.dtypes. So first one is format. So this we already discussed, like it returns a list of strings and tuples, unlike df.schema object. So second one is direct access. So that means it is useful for checking if a specific column exists and what its data type is without iterating through the schema. So that means if you want to check whether column is existing or that relevant data type is available or not. So that means without iterating, the schema, we can directly access these two values. So third one is efficiency. So this is metadata operation and does not trigger a Spark job or scan the data. So that means if you apply this function df.dtypes, so generally for each function, so there will be one Spark job it will create. So whenever you apply this function, so what it telling is it does not create any separate Spark job. So Spark job means it is like scanning the data. So how it will detect column name and their relevant data types is by scanning the data. So final one is filtering. So the main advantage of this function uh, df.dtypes is we can filter the specific data types columns using dictionary comprehension. So in other methods, it is not flexible like this. Okay, so here what we can do is here we can use list comprehension or dictionary comprehension. So here mainly what we are doing is suppose I have one data frame. So in that data frame, I want to filter the columns based on data type. Suppose I want to filter only string columns. Then what I can do is first I will write for loop here. So since my output is df.dtypes output is list of tuples. So if list of string, if like this means if list of string means, then what we can do directly k for k in df.columns we can write. But what we are getting output is list of tuple. So in tuple, we have again two string elements. So since we have two string elements, we have to write here two elements. So one is k comma v. So k is for column name, v is for data type. So here I'm mentioning k. So k means column name. So I'm iterating column names for k comma v in this is my dictionary dot items. So whenever you have dictionary output, so you can use items method to find both the values. Okay, that means key and value. So key and value of dictionary, we can get the output by using this items method. So while iterating each tuple, what I'm giving condition is I'm giving if condition if v is equal to string. So here v is what? So here k comma v. So here first k means key. So key means column name and next is v value. So that is a data type. So that is v is data type. Suppose if it is iterating on first column, suppose if you assume here, so this is our output for df.dtypes. This is our output. So while iterating this one, so if data type is string, then if condition matches. So suppose if this is our input, so here how many strings are there? 1, 2, 3 is there. So total 4 are there. So but strings are only 3. So what it does is it filter only string columns. So out of 4, we'll get only 3 columns. So now we'll jump onto our main uh, topic of this video. So first we'll see what is the content of this video. So first one is how to verify the data type of data frame and how to verify the specific column data type of data frame and how to verify the column type of data frame using for loop and how to return the first columns type if there are multiple columns with the same name. So same column name and how to filter columns by type. Type means data type. So how to verify the column type of the data frame using schema. So these are the different scenarios we are going to look by using this df.types function. So for this, I have one sample data frame. So I'm reading this data frame. And so here I have this many columns. And if you see here, I have different data types here. So I have date is there, string is there, integer is there. Okay, so total 3 types of data types are there. So this we saw already how output it gives and where we are mainly looking is. So on top of sample data frame, what I'm doing here is I'm trying to add some metadata columns here. So what metadata columns I'm adding here is, so here I'm using with column. So first I'm adding column as load underscore date. So up to here it is sample data frame. So on top of this, first I'm adding load underscore date. So how I'm creating this column? By using current underscore date function. In PySpark, current underscore date function, what it does is it print today's date, but this value will be constant. So for entire column, that means if this particular data frame has 100 rows, so all 100 rows, it will print same value. That means today's date. And I'm adding one more column, that is load underscore date. That is this one. So this one, how I'm generating is by using current underscore timestamp function in PySpark. So what it gives is today's timestamp it will give you. So what is the difference between here and here is, here it printing only date. So that is today's date, year, month, date. But here first portion is date, that is year, month, date, and in between T we have, and later we have time. So hour, minute, second, millisecond, and time zone. So this is today's timestamp. Next, I'm adding one more column, that is current underscore user. So here in PySpark, we have function like current underscore user. So what it does is it will print you here, use the user mail ID, it will print either user mail ID or ID it will print. And the last one is reach, that is this one. So here what I'm doing, I'm using lit function here. So in lit function, I given float value. So 10.55. If you see here for all the data frame, this constant value that is 10.55, it will add to this particular column. Now, if you see, these are all the four columns we added newly. So load date is date, load underscore time is timestamp, current underscore user is string, reach is double. Okay, so now what I will do, I'll print one more time df dot print schema. Okay, so df product ID load data df. Okay, I will rerun this one. Okay, so now these new four columns are added here. It's a relevant data type. So now first we'll see our first scenario, like how to verify the data type of the data frame. So that means by using df.dtypes function, it will give you all the list of columns and relevant data types. So here what will get output is it returns the data type of all columns and it returns a list of tuples. So list of tuples. So how these tuples will be, first is column name, second is data type. And if you see here, first and last it is list square bracket, and inside that we have multiple tuples is there. So this is our first tuple. In first tuple, what we have, this is column name, this is data type, and this is second tuple. So this is second column name, second data type, and similar way here, third column, that relevant data type, and so on. And if you see for last one, that is column name is reach, and data type is double. So this how you can verify the data type of the data frame. And same thing. So if I write print statement, so print of df dot data types, it will give you in continuous line. Suppose if you type only df.dtypes, it will give you output like this. So only format, the way of display is different. That's all. Otherwise, it is same. So list and each tuple is showing in line by line. So visually, it is more clear in this here. So second scenario is how to verify the specific column data type of the data frame. So that means here what it doing, it giving the data types for entire data frame. That means it giving all the columns and that relevant data types. Suppose if I want to know this particular column, what is the data type? Then what I can do is we have method like dict method. So from here to here, that means df.dtypes, what will get output is list of tuples. Now, if you apply this dict function on this, so what it does is this list of tuples, it will convert into dictionary. So this one I will show you separately here how it converts. So df.dtypes. So here I will write like, so df.dtypes is this one. So list of tuples. And if I use dictionary dict function, what it does is it will convert to dictionary. See here, starting and ending is the flower bracket. And inside that you can see column and the data type. This is first column data type, second column data type. So that means a dictionary, it giving like key value pair. See here how output is there, list of tuple. This each tuple it converted into dictionary. So dictionary means key value pair it converted. So this is key. So first key is column name and the first value is data type. So second key is column name, second column name, second value is the second data type, and so on. So now dict of df.dtypes is this one. So we have input of dictionary. So in once we get to dictionary, to access any value, so if you pass the key value by using index method, so it will give you output of that relevant value. So that means, so up to here, dict of df.datatypes is our dictionary. So dictionary has key value pairs. And by in dictionary to access the keys, to access the view values, so we have multiple methods. So in that, currently I'm using index method. So in this index method, what I'm giving is I'm passing one of the key. So from this dictionary, I'm passing one of the key. So that is source underscore target. Where it is there, this one, source underscore target. So this is key. Key means that is column name. What it gives output, it will get output that relevant value. So that means the data type will get. So df and data underscore data type, if I print this one, what I will get? This string I will get. That relevant data type I will get. Okay. So now after that, what I'm doing, so df dot limit 5. So I'm printing first 5 rows. Or what we can do is instead of printing everything, so now my output is this one. So what I can do is, so df dot select, df dot select inside that star, and I can mention this d type dot display, and inside, okay, that is fine. So df data type. So here what we are getting string. Okay. So if it is column, then we can do this one. So what I will do instead of this, I will remove this one because here output is string. Suppose if I have column name here, if this is my output is column, then I can display this data frame. That means only that particular column I can display. So since my output is a data type, I cannot do that. So I will show you in some other place. So this is one to verify the column name. So here I given one particular column. So here what you can do is you can change the value. Suppose what what I will do here. So this same thing I will try to add here. Here we checked for uh, one particular column. So here we'll try to see for multiple columns. So for this particular column, we are getting string. So what I will do, I will add few more columns here. So one, I took source underscore target. Next, what I'll do, take sessions. So here I will change to sessions. Next, I will take load underscore date. Next, one more is I'll take reach. So if I print now, I will get all relevant columns, data types I will get. So this we saw already. Next, what we'll see sessions. So here for sessions, what is the data type? Integer. So my second output will be integer. And at the same time, for third one, that is load underscore time. So load underscore time, timestamp is the data type. So that is third one. So next one is, last one is reach. For reach, what is there? Double. So we'll get double. So like this, you can change column here. So we'll get relevant data type. So next scenario is how to verify the column type of a data frame using for loop. So this is by using dict method for verifying the specific column data type of a data frame using dict method. Using dict method. And next, what we are seeing is in next scenario, how to verify the column type of the data frame using for loop. So here, what I'm doing here is, so we know that what is this output, what we'll get for this df.dtypes. So here I'm writing for loop, simple for loop I'm writing here. So next I will show you with the list comprehension how to do that. So first we'll see about how to do with for loop. So for call in df.dtypes. And if you observe one more thing, df.dtypes generally will get two outputs. So if I see here df.dtypes, so here we'll get list of tuples. Okay, so list of tuples. So here what I'm doing here is in list, the first element is this one, that is tuple. Second element is this tuple. Third element is this tuple. So if I iterate this one by using for loop, what will happen? First, it will iterate this tuple. Second, it will iterate this tuple. So now, while iterating this first tuple very first time, what will happen here is, so here, since I given only call, so that means only one parameter I passed here. So if I see here, I will show you separately here, this one only for loop. So for call in df.dtypes. So see here, first tuple, it giving output, and this is second tuple, and this is third tuple. If you go here, so this particular thing it is iterating. That means this is a list of tuples it iterating. In first iteration, we'll get output as this tuple, and second iteration will get this tuple, and third iteration will get this tuple, fourth iteration this tuple, and so on up to reach all the tuples. It will get iterate here. And if you see here, for call in df.dtypes, here what I'm giving print statement, print call. So print call. So that means each tuple it is separate iterating. See here up to reach double. So this is one thing. And one more thing. So here I'm changing small code change. So this iteration is same. So earlier I given print call, but here what I'm doing, print call, I'm adding index as 0. So that means what happens in this first iteration, what is our first iteration output? This one. So this tuple, since I given index 0, what will happen? I will get output of only this one. So this is index 1 and this is index 2. So in first iteration, index 0 is what? Start underscore date. So that I'm getting here. And in second iteration, from this index 0 is this one, product underscore URL. And it will go so on. So that means whatever index 0 from start underscore date to reach, up to reach, it will print one by one. And next, I am changing little bit code. So up to here it is same. And what additionally I'm giving here is I hard coded here like comma, and I given additionally call of index 1 also. So that means, so from here, this is index 0, this is index 1. So as per our syntax, what it will print? First it will print start underscore date, then it will give you comma, then it will give you this one. So that is this one. So call of 0 means index 0 means start date. And since we mentioned comma here, we'll get comma, and call of 1 means this date we will get. So date, how we are getting this one. So index 0 is start underscore date. Index 1 is date. So that is this one. So for each and every tuple, it will get up to reach double will get like this. So this is about how it doing for loop. Now we'll come to actual thing. So this condition is same. So this also we saw now how output will get. And finally, what I'm doing, I'm printing here df dot limit 5. So this our actual data frame it's showing here. This is fine. So this is no need to worry about that. So this one we are getting output here. So whatever we discussed below, same we are getting here. Like this is index 0, comma, index 1, index 0, comma, index 1, and so on. So this how we can iterate the column name and data types to verify the column name and data type. So next one is, this is about iterating. Next, what I'm doing here is how to return the first columns type if there are multiple columns with the same name. Suppose in case column names, if it is same, then how to pick the first column data type. Okay, so for this, what I did, I created one function here, def, and my function name is get underscore df, get underscore dtype, and inside that I'm passing two arguments. So one is df, that is the data frame, and a second one is column name. Okay, so here in return statement, what I given is dtype. So here I'm giving for loop name comma dtype. So name comma d type, this is key value, this is key, and this is value. So this key is column name and this value is data type in df.dtypes. So df.dtypes, we know that it is a list of tuples. So here, uh, how it will iterate. So name comma d type. So that means name comma d type means this is column name, this is d type. So both the key and value, it will iterate one by one. And in that, if name, so this name is this one, column name. If is equal to column name. So here I given column name. That means we need to pass the column name. If that particular column name of index 0, that means first index it has to take. So if the same function, if I call here, so print get underscore d type and data frame is df and I'm passing column name as start underscore date. So for this relevant data type is date. And same way I'm passing one more column that is product underscore URL. That is this one, and relevant data type is string. And similar way for sessions, data type is integer. So I'll get integer here. And similar way for load underscore time. So here load underscore time, data type is timestamp. So I'll get timestamp of this one. So here only thing is df.dtypes. We are iterating both column name and data type. For each iteration, we are checking the column name. Whether whatever we are passing column name, for that, it will check the index. So next one is how to filter columns by type. So that means data type. So same condition, whatever I written here, list compensation, same condition. So only difference is up to here it is same name for name comma d type in df.dtypes. So that means df.dtypes is list of tuples. So in each tuple, column name and value. So this is column name and this is data type. So it will iterate and condition is like if d type. So that means data type, if data type in condition I given, in condition I mentioned these three data types, integer, double, float. If any one of these data types, then we can, those data types we can consider as numeric columns. So what it will do for each and every iteration, it will check whether, suppose if I see my sample data frame, first it will iterate this column, then this relevant data type it will check. Here date is there, but in this list date is not there. It will ignore that one. So next it will come to second one. So here string is there. So this also it is not in this list. So it will ignore. So that means all the strings it will ignore. So wherever integer is there, so here int is there, so then it will consider. So session underscore id, sessions product underscore id. So these three columns it matching to this one. So what it happens, it will print these numeric columns and double also is there. So double, so if I update this one, we'll get here double also. Yeah. So total we have three integers. So one is session underscore id, sessions product underscore id, and next double is reach. So total four columns and we don't have any float. So integer we have three columns, double we have one column. So total, since I'm printing here all numeric columns, so here I'm getting list. So total 4 columns. And these columns, so what output we'll get here is, this is a list of columns. So this list of columns, here I'm passing in this select statement by mentioning star. So from our sample data frame, it will print only these columns. That means these 4 integer columns it will print here. So that means from our data frame, I'm filtering only numeric columns. For same syntax, if I want to print only string related columns, only change is instead of here I given in condition, right? In this. But for numerical columns, we have multiple integer columns like this, integer, double, float. So that's why I given in condition. But in string, we have only one type. So that is the reason I given if d type is equal to string. So now what it happens is for each and every iteration, it will check the data type. So date, it is not matching. Next in second iteration, string is there. It will consider. In third iteration, string is there. So wherever string is there, it will consider all those columns. So this one, next it will ignore this one. Next it will consider these 3 columns. Next it will ignore these 2. Next it will consider this one. Next it will consider this one. So now string underscore calls. So all these columns it listed here, all the string columns. And this string underscore calls I'm passing here in this select statement by using star. So from our sample data frame, instead of displaying all the columns, it will display the columns only of this, that is string columns. That is this. See here, it is displaying here only string columns. So here it displayed only integer related columns. Here it is displaying only string related columns. So next, how to verify the column type of the data frame using schema. So this we already saw, like df.print scheme. So printing the schema of the data frame using print schema function. So in print schema function, it will only like visual representation. So first one will be like row, and for each row, it will be like first column name, then data type, and inside that whether nullable is true or false. So for all the columns, it will display like this in graphical representation. So that's all about this video on how to use df.dtypes function in PySpark. If you really like this video, please like and subscribe. Thank you.